Welcome back. In our previous class, we've seen how imbibition and drainage occur. And now we're gonna just check again on a more complex medium. So please, take a look at this figure here now. Well, we have a nice video for you, so pay a close attention and we'll talk about later. Take a look. Well, now I'm going to give you some more details about that. I'm going to show you what happens. Well, let's explain a little bit what's happening here. Here are entry ports. So we have entry ports that have a very small size, very small radius. But as we realize from the shape of this meniscus, look, I can clearly say or state that the red is the wetting fluid and the blue is the non-wetting fluid. Same here or here. Take a look at the meniscus. The black dots are the solid material, okay, of the porous medium. Well, so from what we've seen, the wetting fluid is invading from here, from top to bottom. And the openings at the ends here, at the top end, you can see here. There's an opening here and a smaller one here, much smaller one here, a large one here, small, large, large, small. Okay, let's repeat and see. We have already some irreducible water inside or some water left behind. And we'll see how the imbibition, how the wetting fluid will going to remove the non-wetting fluid and leave behind some residuals. Take a look. Okay, so look at here. Look at here. It's pushing. It's large. It pushes clearly. Look, here is large now. It's pushing. Well, but then it gets smaller here, you see? That is very likely that's going to break up at some point. Oops, it broke up and it moved and it left behind this huge blob of residual phase and these two smaller ones, you see? You realize that the wetting fluid tends to follow larger pores, and the non-wetting, the blue, tends to follow the larger pores, and the wetting follows the smaller pores. Well, as an option following smaller pores, it eventually leaves behind residuals. Take a look again. It invades from the bottom here, oops, an opening here, so it adds pressure to this point. Now we have an opening here. Now it's adding pressure to this side, to this side, to this side, to all the sides is adding pressure. Pressure here, here, breaks up here, and now breaks up here, and we have residuals left behind. That's quite interesting. I'll show you why this happened in much more detail in a few next slides. Well, again, what I do recommend is that you take a close look. Take, for example, a small pore region first, then another pore region, then another one, and then you focus on the ones that you know is going to have a snap off or a breakup, and you see how these guys are left behind. Okay? Well, let's go to our next slide. Our next slide then you see it's filled with wetting fluid, right? And we will have some non-wetting fluid invading, the blue one, and we will see that guy displacing the wetting fluid, the non-wetting displacing the wetting, drainage, okay? So, again, we watch the movie and then we make some comments. Okay, that is nice. So take a look. Large pore, whoa, big invasion. Now smaller, oh, large, very large. Look at that. Whoa, big invasion. Here is very large. Look, it's invading all through the larger first, large. And it ends here with a small opening to leave. So it needs a lot of pressure to invade. So if needs pressure here, all the other guys here have opportunities to invade better side. Look, it is invading small. This guy is a bit of in a trap here, okay? You see, all small here, small, until one guy here, through a larger pressure, invades the small one. Then once it invades, and you have a loss of pressure, and everybody invades to that position. Again, take a look. Large pore, big invasion. Ooh. Sequences of smaller pores here. The large ones are taking the chance. You see, very small, and invades a bit eventually here. Look, but then it traps. It's trapped again in a smaller pore. This is very small. It's not gonna move. So if you compare the size of the pores after the invasion of one of these guys here, the whole situation stopped. And we see that we ended up with irreducible water left behind. Okay, so what defines the flow is the shape of the porous medium. Okay, the geometry, pore geometry defines that. Well, now you've seen in a more complex way, and I do recommend you again that you take a close look to whatever you've seen there. Take the movies and watch them over and over again until you get used to that information and you understand why the pores that were picked. Okay? Well, let's go to our next slide then. In our next slide, we'll talk about imbibition. I'm just going to show you another situation. I'm not going to talk too much about that, and you understand what's happening here already. The wetting fluid invades. You get a very large meniscus. You can see the large meniscus here. And it's going to touch here, and it's going to split in two, and you can tell me what's going to happen from there on. Look. Please. Don't sleep. Don't fall asleep. Oops. Look. Larger pore here now. Reaches here and it gets larger and it tends to move here. Well, that's the fun of it. We're not gonna wait until the whole thing happens. But you see and you understand that the size of the meniscus defined the whole movement of the fluid, the invasion. The fluid invasion is actually defined by the size of the pore. Should you have a very large pore and you realize that your fluid will have a hard time to displace the non-wetting phase due to very large meniscus. You don't have enough capillary pressure to push it. Okay? Again and again. Please take a close look at the movie and understand the size of the meniscus. The size of the radius will define how free phase becomes a residual phase. And we'll see that in our next slide. Well, take a look at this imbibition here. We have wetting fluid all over here. So what we have here is a capillary tube that varies its radius. Okay? So we have one radius here, another one here. So the various radii here are different, small, larger. Well, if we're going to go through imbibition, we're going to have a wetting fluid displacing the non-wetting fluid. Well, if we have a wetting fluid displacing the non-wetting fluid, you should imagine that this guy here is wetting, it's non-wetting fluid. And let's see how it goes. Look, it is displacing. But pay a close attention now. It's getting thicker with, it's getting thicker here with wetting fluid. And it develops a wetting fluid collar until it snaps off. It's getting thicker, it's developing a wetting fluid collar until it snaps off. Again, wow, this is nice, isn't it? Well, this is one way, and if you wanna go back to the previous to our previous slides, to previous movies, you will see why this situation happens on a more complex porous medium. Take a look at that. I'm going to show you here. Look, this is the situation. As the water or the wetting fluid invades here, it tends to invade the wall beneath the wall that is close to the non-wetting fluid here, and again here. As it invades here, because here is much smaller pore for him, it tends to decrease even more the radius for the non-wetting fluid. Well, if the non-wetting fluid doesn't wanna invade the smaller pore already, and you're trying to push him to this smaller pore, and if the smaller pore it's getting even smaller, well, if it's getting even smaller, how can you push it harder? You add some extra strength, some more capillary forces, and it snaps off. And that's why it's left behind as a residual phase. Okay, so let's take a look again at the movie, and you understand what's going on. Take a look at here now. Look, now we'll have our situation. Look at this, only this part here, and see how the radius for the yellow fluid is getting smaller. Now here, the radius, you see the wetting fluid color, the radius for the yellow fluid is getting smaller until it snaps off. Same thing here. Radius is getting smaller until it snaps off. This is how we have the formation of residual phase. Of course, this is our simplest structure. We have just a single capillary tubing showing us what's going on. In a field situation, we have a much more complex. We have several ways and pores connected that the fluid can take and can pick. So we have difficulty to get them going. Okay? Well, and this shows us what happens. Well, let's go for the next one then. Now we have difference in radius is not that big. And if the difference in radius is not that big, we see what happens now. Well, the fluid, the wetting fluid, is able to push through a smaller but not that small pore. So the wetting fluid is being displaced from all the pores, and we don't have the formation of a residual phase in our situation now. So what I would like you to do is get this same situation here and use it back and try to think of that same situation in our previous movies and do a better understanding. Okay? This, although it looks very simple, you have to make some use and some thinking and get used to that information so you can understand a real situation in the field. We're going to talk about that in our tutorial sessions on some real situations for you to understand. Okay? Thank you.